To better understand the injection molding process requires understanding some properties inherent in plastic itself. The simplest definition of a plastic is any natural or synthetic polymer that has a high molecular weight. There are two types of plastics: thermoplastic and thermosets. Thermoplastics undergo a reversible change from solid to liquid when heated, and can be cooled and reground for reuse over and over again. Thermosets undergo a chemical reaction between two reagents when heated, and achieve their strength through the interlocking chemical bonds. Once molded, thermosets cannot be resoftened. While thermosets are injection moldable, most materials used in injection molding machines are thermoplastics. Injection molding plastics is extremely complicated because of the infinitely changing pressure, temperature, and velocity inside the mold. These molding conditions directly affect the properties of each molded part. A change in any of the conditions will alter the parts produced. There are four primary elements that influence the plastic injection molding process: the molder, the material, the injection machine, and the mold. There are a variety of injection molding machines in use today. The vast majority of these machines are hydraulically actuated and have 3 platens. But newer styles, such as 2-platen injection molding machines and electric injection molding machines, are now gaining market acceptance. Injection molding machines range in size and complexity from desk-size units up to machines the size of a small house. Most injection molding machines are horizontally oriented, but vertically oriented molding machines are available. These vertical machines are primarily used for insert molding. All injection molding machines are a combination of 2 systems: an injection system and a clamping system. The injection system heats the thermoplastic material to its appropriate viscosity or flowability and then forcefully injects it into the mold. There are 2 types of injection mechanisms: the reciprocating screw, which is the most common, and the 2-stage screw. The main parts of the reciprocating screw injection system are the hopper, a reciprocating screw inside an externally heated injection barrel, a hydraulic motor, and an injection cylinder. Resin material is fed to the injection barrel from the hopper. These hoppers may be filled manually or vacuum-fed automatically, and often have dryers attached to the top to remove the moisture from the material. As the resin enters the injection barrel, it is driven forward by the rotation of the screw, which is powered by the hydraulic motor. The resin plasticizes or melts as the turning screw drags it towards the nozzle end. This is referred to as drag flow. Drag flow causes the polymer molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the injection barrel. The heating bands bring the material to its final temperature and compensate for the radiation heat loss. The temperature is controlled by 3 thermocouples in the barrel and 1 in the nozzle. Over time, many different mold designs have been developed that meet specific injection molding requirements. These mold designs include the Cold Runner 2-plate mold, the Cold Runner 3-plate mold, the Hot Runner mold, and the Insulated Runner mold. The Cold Runner 2-plate mold consists of 2 plates with the mold cavity and core mounted on them. The Cold Runner system molds the sprue, runners, and gate along with the parts. After ejection, the parts are separated and the rest reground. The Cold Runner 3-plate mold uses 3 plates to mold the part. These plates include the stripper plate, which contains the sprue, the middle or cavity plate, which holds the cavity, runner, and gate, and the movable plate, which holds the molded part. This type of cold runner mold design automatically separates the runner system from the part as the mold opens and is very easy to automate. The hot runner mold uses an electrically heated manifold that keeps the molten thermoplastic in the runners at the same temperature as the heating cylinder. The heated runner system is contained in a plate of its own and does not open during the molding cycle. Because of this, hot runner molds generate no runners or sprues. For this reason, hot runner molding, also known as runnerless molding, is fast and efficient. The insulated runner mold is much like the hot runner mold, but it uses a large diameter runner. During injection, the outer surface of the runner freezes. This insulates the center material, keeping it at the molding temperature.